Alright, today starts our lessons on polynomials. So we're going to start off with a bunch of vocabulary. So a polynomial looks something like this. We have a coefficient and then an x with an exponent, and then another coefficient, and our next exponent is going to be at least one lower than the previous one. And it'll keep on going on until we get down to just an x term and a constant term. So we will always like our polynomial functions to be written in standard form. And standard form for a polynomial is very similar to standard form of quadratics. The exponents go from greatest to least. When written in standard form, it'll be easiest to find the greatest exponent because it'll be first, but in general, the greatest exponent represents the degree of our polynomial. The term containing the highest exponent, because it's at the beginning when it's in standard form, is called the leading term. The coefficient of the leading term, which will be the number in front of the x with the highest exponent, is called the leading coefficient. And the term of degree 0, meaning that there is no x, is called the constant. So, constant is when there's a degree of 0, and this is going to be something like f of x equals 5. There's no x terms after the equal sign. If it's a degree of 1, you spent most of Algebra 1 learning about first degree polynomials. They're called linear because they make a line when you graph them. So this would be something like f of x equals 3x minus 7. Our second degree polynomials, we just spent the last couple months learning about. What's it called when we have an x squared in our function? Hopefully you remember, it's quadratic. Third degree means we have an x to the third power, which we learned about in our first unit of functions. These, hopefully you recall, are called cubics. And then a fourth degree polynomial is called a quartic, and it's going to look something like f of x equals negative 5x to the fourth minus 2x squared plus 4. The highest exponent is 4, and we could have an x cubed term or an x term in there if we wanted. This is just a random example. So let's put this vocabulary to use. Now, determine if the following are polynomials. In order to be a polynomial, the exponent must be positive and no x's in denominators of fractions. Sorry, the exponents have to be positive numbers. They cannot be variables, and no x's in denominators of fractions. So number 1, 8a to the 5th. The exponent is positive, so yes, this is a polynomial. Standard form, since we only have one term, it'll also be the first term. The leading term, 8a to the 5th. The degree would be 5. And the leading coefficient would be 8. Do you think number 2 is a polynomial? Hopefully you said it's not a polynomial, and that's because it has a negative exponent there. And number 3. Yes, this is a polynomial because it has a positive exponent. This one technically has an exponent of 1. Standard form, we want the highest exponent to come first. So 9x cubed plus 2x, which makes our leading term 9x cubed. The degree would be 3, and the leading coefficient would be 9.